All right. Hey, everybody. Uh, Welcome to the fall 2020 semester of Calculus 2. I am going to be your professor this semester. My name is Dr. Ross. I am so excited to get to see you all next week and to begin this extremely interesting, extremely creative, very different semester of Calculus 2 together. I am confident that collectively, the group of us are going to have a fantastic time. We're going to have a lot of fun. We're going to learn a lot of math. We're going to build a strong community and a strong cohort. And yeah, I think it's going to be great. I wanted to introduce myself very briefly and then also talk a little bit about what I think calculus is, what I think we will learn in Calc 2, and a little bit about the course structure. So let's get into it. First of all, introducing me. For those of you who don't know me, I am a mathematician here at Southwestern. I've been here for 5 years now. I'm starting my 6th year, which is crazy to say, but there it is. What else can I say? I am originally from the East Coast, from Baltimore, Maryland, before I moved down here to Georgetown. I live here with my wife and my cat, Carrot Cat, who is an orange rescue that we got about 2 years ago. When I'm not doing math here in my office, you can often find me drinking coffee somewhere in town. I drink a lot of coffee. You can see my collection of coffee mugs behind me. I got this just off screen. So you can find me in town drinking coffee. You can find me trying to go for a run on the Georgetown trails. You can find me playing board games. I'm a huge fan of board games. And yeah, honestly, you'll find me a lot of the time here in my office, working, interacting with you all, interacting with students, or doing some math research. So that's a little bit about me. I am so excited to get to know all of you a little better. Let's pivot here and talk a little bit about calculus, what I think it is to me, and what it will be this upcoming semester. All right, so if I've done this right, we should be recording again, perfect. And if I've done this right, you should see Calculus 2, quick introduction here on the screen. So I wanted to talk a little bit about what I think calculus is. And if you Google calculus, you will often see some version of the phrase, calculus is the study of continuous change. This is absolutely correct, although as we'll see, it is so much more than that. Calculus is the study of functions that are continuously changing, meaning you can draw them without picking up your pencil. You can imagine these describing any number of things in the real world, and we want to better understand how these functions are changing, and we want to be able to describe them precisely and be able to use these precise descriptions to understand their behavior and to predict their future behavior. And this comes primarily in two flavors, especially in Calculus 1. This comes in two flavors, the derivative and the integral. Derivatives are used to describe the rate at which a function changes its height, right? And we'll talk more about this, of course, as we get back into the swing of things. While integrals are used to describe the rate at which a function accumulates area underneath it. And then derivatives and integrals are connected to each other, are related to each other in this very deep way using the fundamental theorem of calculus. And so there's this very natural flow to a Calculus 1 semester. We introduce derivatives and talk about their uses. We introduce integrals and talk about their uses. And then we realize near the end of the semester, there's this very deep connection between the two. That is in the content of the fundamental theorem of calculus. Okay, so what else is calculus beyond this? More than just the study of continuous change and of derivatives and integrals, calculus is the study of the relationship between linearity and nonlinearity. And by that I mean sort of linear functions and nonlinear functions. A linear function, of course, is just a straight line, right? Or something that we could graph in a straight line. While a nonlinear function has a sort of curviness to it. Linear functions are much more straightforward to understand, right? We know how to come up with the equation of a line. We all remember, or we've heard vaguely in the past, y equals mx plus b. And so we know that we can describe a line with its slope and its intercept. And in a lot of senses, we can really, really completely understand a line. While a nonlinear function, by virtue of being curvy, by virtue of being nonlinear, is much harder to understand. And so calculus gives us tools to translate between linearity and nonlinearity and helps us understand the extent to which nonlinear functions can be approximated by linear functions. So to what extent can we understand a nonlinear function by approximating it using a linear function? And this was tied up in the topic, Calculus 1 topic of linear approximation, in which case the derivative played a central role by figuring out which line was the best line to approximate the function. What else is calculus? Calculus is a set of tools that help us better understand these continuous and smooth functions. So a wide range of tools, and as we said before, in better understanding these functions, we can predict the behavior of the functions and predict the future behavior of the function, right? So if we have a function and it's defined up to the present moment in time, we might be able to use the tools from calculus to predict what the function will look like just a little bit into the future, right? This gives us the ability to better model, better understand, and better predict the world, right? So at its core, calculus is the study of change, but the ramifications mean that we can better understand and predict, what will happen in future events. And we'll talk about that this semester as well. So I wanted to remind you briefly some of the tools that we learned in calculus. I think all of these are things that we at least touched on in Calculus 1 a little bit. These include tools from pre-calculus, things like algebra, things like trig functions, exponential and logarithmic functions, and all of the sort of tinkering and playing around with algebraic manipulation that comes with these sets of functions. We also learned about the three, big Calculus 1 topics: limits, derivatives, and integrals, which I just realized is different than the way it's written on the slide: derivatives, integrals, and limits. Specifically, we learned how to compute some of these things. We learned some basic derivative computations. We learned the product rule, the chain rule, all these rules. And then we learned how to interpret these derivatives. So we've calculated the derivative of sine. We see that it's cosine. And then we learn a little bit about how we can interpret that. What does that mean? What conclusions can we draw? Similarly, we learn a little bit about integral computation and a little bit about integral interpretation. More on that in a moment. We learn about limits and how to interpret limits. And we also have a set of major theorems, such as the fundamental theorem, the intermediate value theorem, and mean value theorem. In Calculus 2, we are going to expand this list, expand this set of tools. We're going to do so in the following way. First of all, we are going to really, really hone in on integral computation and interpretation. This was done near the end of Calculus 1, but we want to become much better at integral computations, and we want to explore a whole host of ways in which we can use integrals to solve, application problems and to interpret information in a variety of different situations. Finally, we are going to explore, some very advanced, very fun topics, including the interplay between finite quantities and infinity, the solving of equations that involve derivatives and integrals. This is an introduction to a field of mathematics called differential equations, and we'll dip our toes in it here in Calc2. And we'll explore the ability to understand a function to the largest extent possible solely by looking at its derivatives. So think about on our previous slide, too far, we talked about the relationship between linearity and nonlinear functions and the extent to which the derivative played a role. We are going to see how knowing more derivatives helps us even better understand and even better approximate a function. So these are all topics that we will learn here in Calculus 2. Now, as far as the content goes, the content will essentially be what we just said, split into 3 bullet points. First, we're starting off with more integration stuff, and the first section of the semester will be spent learning more advanced techniques of integration. So our goal is to get good at integrating, and we'll have a lot of practice doing this. The middle part of the semester will focus on different applications to integration. So now that we're good at it, right, we put in all that practice, what kind of questions can we actually answer? So what was the point of getting good? It lets us answer these much more advanced, more interesting questions that we haven't been able to answer before. And the final part of the semester will feel like a little bit of a detour. We will focus on a new kind of accumulation, what we'll call infinite summation, what will ultimately be called a series. Our goal here will be to, first of all, understand these objects called series in their own right and see some connections between series and integrals. And then we will see how we can use our series knowledge to even better understand functions. Again, tying in these objects called series with integration, with differentiation to give us our most complete picture yet of the calculus landscape. I want to end this video just by giving you a quick overview of what our semester will look like. So what's our semester structure? Okay, so first of all, we will have a weekly structure, maybe I should even say a daily structure, in which we watch a short video ahead of class to become oriented to a new skill, and then we spend our class time working collaboratively to practice that skill. That will be sort of our day in, day out, what the class time in our class will look like. Then every week, we will take a quiz. This will be done remotely through Moodle. We'll take a quiz on the skills that we've learned that week. And then a few times throughout the semester, approximately monthly, we'll take a larger test covering everything that we've done so far. Beyond that, right, watching the videos to prepare for class, taking the quiz every week, there will be extra practice problems assigned. That's sort of homework, but that will be 100% optional. I will encourage you to do those problems so that you can continue practicing, but I won't require you to do that, right? Instead, I want you to focus primarily on the collaborative effort that we'll be pursuing in each and every class. And we'll talk about this a little more in class, so you'll get a sense of where we're going and what's expected of you. The weekly quizzes will be graded on a mastery-based scale. And what that means is that rather than give you like sort of different graded levels of partial credit on your quiz, you will either get grades suggesting that you've mastered the skills of that week, or you have not yet mastered them. And at that point, you will have multiple opportunities to improve your grade and to show that you have mastered the skill. So it lets you, instead of settling for some sort of partial credit and an incomplete understanding of the material, you will be incentivized and encouraged to go back to the previous material, to review it, and to take a quiz again, showing that you've mastered the skill and then getting full credit for having mastered it. There are lots of advantages of this mastery-based system, which again, I'm happy to talk about to you in class or individually. Finally, I just wanted to say, because this is, let me turn on my light here, because this is an unusual semester, and because, you know, there is a good chance that throughout the semester, a number of you might be fully remote students, a number of you might be students who are coming to class in person, but end up needing to self-isolate or self-quarantine for a certain amount of time. There's a good chance that at any given day, a number of students won't be able to attend physically in person. Those students, remote students, you will be able to use Ring Central to participate in the class in real time. So regardless of whether you're here on campus, you're self-quarantining, or you're full-time remote, we will all be gathering at the same time every day to work on this collaborative Calculus 2 effort together. So that's all I have for this video. Again, I'm so looking forward to seeing you all here next week. Take care, safe travels back to campus if you're coming back to campus, and I'll see you soon. All right, take care.